Hi, and welcome to the video presentation of bikebot, a Facebook Messenger chatbot. The sole student of this project's name is Giovanni Fisciardi and was responsible for all aspects of research, design, development and testing of the project. A short overview shows what the application does. The application is a chatbot that is built on the Facebook Messenger platform and supplies the chat interface for the user and chatbot to communicate. The chatbot implements natural language processing techniques to allow this communication between the user and the chatbot. The application connects to the Dublin Bike Scheme API and can retrieve information on the availability of bikes and parking spaces at specific street stations. This information can also be displayed in a Google map. The application connects to the Google Maps API and can display information on free bikes and parking spaces available and also give directions, distance, and journey time to the user. In the development of bikebot, new technologies were introduced to the student. The main programming language of the application was JavaScript's server-side platform language Node.js. Node package modules allowed for integration of powerful libraries like Natural.js for NLP and Requestify.js for HTTP requests to the Dublin Bikes and Google Maps API. The application was deployed on a Heroku server, which is a cloud-based platform that can deploy, run and manage applications written in Node.js. The chatbot application connects to the Facebook Messenger API and gives the chatbot a user interface with tools like buttons, template cards and current location. The next section will show a screencast of the chatbot application in use. 4 tasks will be shown. The first, greeting the chatbot. The second task, retrieving an available bike on a specific street. The third task, retrieving an available bike close to the user's location. And finally, the fourth task, finding a parking space to return a bike after a journey is complete. The user is greeted by the app page on the Facebook Messenger application. The user initiates the conversation with a keyword hi or hello. The chatbot uses the NLP implemented into the application to process the user's sentence and find the appropriate response in a knowledge base of replies. The user in this task again starts the conversation with the chatbot. The user is prompted to help the chatbot find what the user is looking for, a bike or a parking space. The user can type or select the quick reply buttons to continue the conversation. The user is prompted again with a quick reply button of sending your current location, or they can type the name of the street they are looking for. The chatbot will return how many bikes or spaces available at that selected station. The next task shows how a user can find an available bike relative to their location. In this task, the user will use the quick reply buttons prompted by the chatbot to complete the tasks. When the location button is selected, a map from the Facebook Messenger application will load, with your current location with a pin. For demo purposes, the pin has been moved closer to the Dublin city centre. The chatbot replies with a card with all the information from a station closest to the location. The card displays a map with directions between the user and the station with an available bike. Extra information is provided with how many bikes available, the distance in kilometres and duration of the journey walking. Extra stations are also available to give the user extra options in case they do not want to go to the first option supplied. The next task shows how a user can find a parking space after completing a journey. The user can select the quick replies or ask the chatbot for parking. Similar to the last task, the user can drop a pin on their current location. For demo purposes, again the pin is dropped into the city centre. The chatbot replies with a card with the information from the nearest station. Similar to the card from the previous task, it includes a Google map with directions between the user's location and the station's location. It also includes the distance and cycling journey time. Extra station options are available to the user if they do not want to use the first option. Extra functions help the overall usability of the chatbot. The WTF engine creates response templates that help the application to randomize responses and give the user a feeling of uniqueness of each conversation. This demo shows the user sending hi to the chatbot, but the responses from the chatbot are slightly different every time. Spell checking is an important NLP section of the project. This improves the usability of the chatbot and makes the application very forgiving to use. The first misspelled sentence in this demo shows how the chatbot can understand what the user is looking for, even though they haven't written it correctly. The chatbot uses a corpus of correctly spelled words and Dublin street names to calculate what the user may be trying to say. With future development of the chatbot application, the developer would like to add a more in-depth knowledge base to handle more ways that the user would communicate with the chatbot. To add machine learning elements to train the chatbot on user queries and become more accurate with responses. Add speech recognition to allow the user to communicate in different ways and not solely with text. And also would investigate the possibility of integrating other major cities' bike schemes in the application. Overall, the project was a success as it achieved its goals of implementing NLP techniques to allow the user to interact using natural language with the application. With the implementation of NLP, it allows a user to query the chatbot in many different ways and still get the same desired result. The chatbot application has the ability to process a user's sentence and check if there's any spelling mistakes, select an appropriate response by using a knowledge base, retrieve data from the Dublin Bikes API, and display Dublin Bikes data in Google Maps with directions, distance and journey times. The application was ambitious and explored new technologies and pushed the student to develop an application that was different to previous projects completed over the past 4 years. The project also allowed the student to gain a lot of experience in project management from completing this project. Thank you for watching.